But how natural is anything that we eat? I happen to share Anne's curiosity about food. Despite having worked in plant genetics for many years, there's still a lot that I don't know. So I've decided to set out on a journey to find out more about the nature of food and where food comes from. And to do this, I want to start at the beginning, with the origins of agriculture itself. I've come to Mexico, where many thousands of years ago, our American hunter-gatherer ancestors first learned how to grow their own food. One of the most important crops that we use today is corn, which we find in everything from fizzy drinks to tortilla chips. And in fact, corn was one of the first crops to be grown in the Americas. But soon I discover a remarkable fact. The corn we know today is very unlike the corn grown by our ancestors, and their corn too was unlike anything to be found in nature. According to agricultural historian Professor Garcia Barcena, the plant from which corn was derived had cobs which were too small to be useful, and therefore had to be modified by the earliest American farmers.
Let me make sure I understand what you're saying, that corn wasn't made by nature, it was really made by early man 10,000 years ago.
Sure it is, because the original corn has cobs about 1 inch long at most, and very small seeds, surplus of them. And it's not a very attractive plant as a cultivated one. It had to be very highly modified to be useful.
So if corn hasn't always looked like it does today, what did it look like before? And how did these early farmers manage to alter its natural characteristics? To find out more, I decided to visit the International Crop Research Institute just outside Mexico City. Plant scientists Julian Berthaud and Brent Skovman have promised to show me the primitive plant from which our corn is derived.
Look, there's the primitive ear of corn. Looks utterly useless.
Yeah, this is almost, let's say, it's an ancestor of corn. It's called here in Mexico teosintli.
So this couldn't be eaten as a food at all?
It could have been some time ago, because if you put it on a fire, in a fireplace, it would pop, just like a popcorn.
But it's not very productive, though.
No, especially it's very difficult to harvest it, because we have to pick every seed by hand and one by one.
So the domestication involved going from this small little cob-like structure in which the seed just fell out to something very large like this.
Exactly.
And even larger like this.
Corn.
So the corn cob that I eat was made by man and not by nature.
Not by nature, just by man.
So how did this happen? In any crop, farmers have always found that there are one or two plants that are different. This is simply because of natural genetic mutation or the accidental crossing of different plant strains. But occasionally, these new plants have traits which are useful, so farmers would come across corn plants, for example, with large cobs, or cobs which didn't drop their seeds, or cobs with fewer toxic compounds used in nature to fight off insects and other pests. Left to nature, many of these novel varieties would simply die out, but farmers have intervened to protect the plants they like and encourage more of them to grow. In this way, by breaking the laws of natural selection, farmers have managed to create new plants to better suit our needs. Look at these pumpkins. Look at the variety in shapes, in colors. All of this is due to natural mutations, just changing the plant. And what man did 10,000 years ago was to be able to use this variety of genetic information to select from the small corn to the larger corn, to select from this small gourd to this huge pumpkin that I can hardly pick up. These things are related to each other. They're identical, but look at the differences in the size, simply due to one or a few genes. And this is really genetics at work, and this is what man has been able to do. Agricultural historians say that even wheat has not always existed, but was rather the result of two strains of wild grass, accidentally crossbreeding, and then being selected by primitive farmers.
So this has genes from different species combined into one nucleus, into one plant.
This has genes from different species in one plant.
And those...
And this was accidental by nature, but then it was selected by man, because you had to select for the good characters to domesticate this wheat. And I say man, I should probably say woman, because I'm almost 100% sure that it was the women that domesticated the plant species.
Strange as it may seem, it was this process of primitive genetic modification which has created the fruits and vegetables that we use today.
They didn't have broccoli, they didn't have Brussels sprouts, they really didn't have wheat, they certainly didn't have corn, they didn't have soybean, they didn't have tomatoes. Nearly all of the things that we see in our shops today and we enjoy were not there provided by nature. They've really been developed by genetics and selection, by man, constantly intervening and selecting to serve his purposes.
Humankind has been genetically modifying plants since more than 10,000 years ago. This has been done using primitive ways of genetic modification, and Mexico has contributed in an enormous way to agriculture by creating corn and tomatoes and beans, the modern varieties that we use in agriculture.
But the advent of agriculture meant far more than the development of new types of food.
When man changed from being a hunter-gatherer to adopting agriculture, that meant that they could stay in one place, and that created opportunities for a very new kind of social structure and civilization. And so it has been throughout the ages. There's a very strong thesis that indeed agriculture has been one of the major platforms to allow civilization to develop.
The transition from hunter-gathering to farming involved a whole lot of other stuff. It involved the development of a primitive science and technology, often expressing itself as religion. It involved the development of a complex social organization. It involved the development of architecture. In essence, the development of agriculture was the development of civilization itself.
As civilization progressed in the ancient Near East and Europe, so did the technology that was used for farming. From around 4000 BC, the ox-drawn plow cut through European soil, and the invention of the wheel and the water wheel represented big leaps forward in agriculture. In the Americas, the primitive character of farming tools and the absence of farm livestock held back the development of agriculture at least until the 15th century, when the Europeans arrived.
Primitive agriculture led to the domestication of many different varieties of animals and plants. In the most civilized parts of the world, other innovations in farming followed, like the development of complex irrigation systems. But by today's standards, the application of science was very rudimentary. However, events occurring in medieval Europe were about to change all of this.
As commerce increased in the later Middle Ages, towns began to expand around the fortifications of medieval Europe. More and more people were leaving the land and turning to trade, but they still needed to eat. And so, in order to produce more food, Europe began to turn away from subsistence peasant farming and towards large-scale farming. And with that change came an increasingly scientific understanding of how plants work. To find out more, I've come to Dover Castle in England to meet food and agriculture professor Ted Collins.
Ted, what was happening during this period to towns and cities?
Towns were expanding rapidly during this time, and this meant a large non-agricultural population that had to be fed.
And this couldn't have been done with the peasant farming of the time?
There was one fundamental difference between peasant farming and capitalist farming. Peasant farming, the principal aim and objective was to employ and to sustain a family. With the capitalist farm, it was different. The objective there was to produce surpluses to feed growing cities like Paris and London.
So there were large increases in the yield of the crops that were produced?
Yes, indeed, there were.
In the centuries that followed, there was steady progress in agricultural techniques. Farmers embraced crop rotation, and they developed new machines for planting seeds and threshing, and better ways to plow the land. And these technologies brought much-needed improvements in agricultural productivity. Exciting things were happening in Europe. How were these changes translated into the Americas?
Well, the discovery of the New World, if we can call it that, was obviously going to be a major watershed here. But it's a two-way traffic. The settlers who followed Columbus brought with them lots of European crops, domesticated livestock, and European farming ideas. And coming back the other way, we would have American crops. And the two most important crops were maize and potatoes. And they played a major, major role in feeding the growing millions of Europe, especially in the 18th and early 19th centuries.
But the historical significance of this innovation went far beyond improving agricultural productivity. From the 16th and 17th centuries onwards, people were developing a properly scientific understanding of the world around them. The Age of Enlightenment had arrived.
The Enlightenment was a crucial phase in human development. For the first time, people began to positively embrace science. Even people who weren't scientists began to sort of try new things out on their land or in a particular business, with the belief that if they somehow discovered some new way of doing things, their life would improve for the better.
People began to ask questions about the natural world and about how things grew. People wanted to try to find out, and on the basis of their results, to try and develop sort of improved practices. And the whole aim of this was communication, was experiment, was dissemination of ideas, and in fact just looking at things differently than ever before.
Human beings were no longer regarded as passive subjects who could no longer change circumstances, who were fatalistically at the mercy of natural forces. On the contrary, human beings now were regarded as authors of their own destiny. It was now expected that the future would be very different than the past, because people had the capacity to change their circumstances, transform the way they lived, transform the way they produced, transform their economies, change their culture. And because of that, people began to have a more optimistic view of both change and also of the future.
By the 19th century, important advances were being made in agricultural science, such as the discovery that plants need nutrients and the discovery of genetics by the monk Gregor Mendel. But at the same time, thanks to advances in hygiene and medical science, population levels were rapidly increasing. So much so that by the beginning of the 20th century, a leap forward in agricultural techniques was badly needed.